Make A the subject of the formula. S equals ut plus a half at squared. So we want to get A all on its own. So the A is here at the moment. So we're going to have to get rid of the ut first of all, because the half and the t squared are stuck onto the A, so we have to leave them till the end. So if I want to get rid of ut, I'm going to have to minus ut, so that they cancel out. And if I minus ut to the right of the equal sign, I have to minus ut to the left of the equal sign. So I have s minus ut on the left. Another way of looking at this is saying that I carried the ut over the equal sign and became minus ut. Either way, you've got s minus ut on the left of the equal sign, and on the right of the equal sign you still just have a half at squared. So remember, I want to get the a in its own. I've got a half stuck onto the front and t squared stuck onto the back. But because all of these are stuck together, they're all multiplied, and the opposite of multiply is divide. So I'm going to have to divide by a half t squared to get the a in its own, and that will cancel out the half and the t squared. But if I divide by a half t squared on the right of the equal sign, I have to divide by a half t squared on the left of the equal sign. So I'm going to get a on its own over here, and it's going to be s minus ut over 1 divided by t squared over 2. So the s minus ut I'm just going to put over 1 so that I turn it into a fraction. And a half t squared I can change to t squared over 2. This means the exact same thing. Now I'm dividing two fractions, and the rule for dividing fractions is turn the second fraction upside down and change the divide to multiply. So I still have a equals s minus ut over 1, and now I have multiplied by 2 over t squared. So we do top by top, bottom by bottom. So it's going to be s minus ut multiplied by 2 and 1 by t squared. So top by top, bottom by bottom. So I can just stick the 2 on to the s minus ut with brackets around it, and 1 times t squared is t squared. So now a is the subject of the formula. Make or the subject of the formula. A equals p times 1 plus or over 100. Okay, so we want to get this or on its own, and the first thing we have to do is get rid of the p that's stuck onto the front of the bracket. Brackets mean multiply in maths, and the opposite of multiply is divide. So if I divide by p, I can cancel out those p's. But if I divide by p on the right of the equal sign, I have to divide by p on the left of the equal sign. So a divided by p is just going to be a over p, and this is equal to 1 plus or over 100. So I've gotten rid of the brackets now because I've gotten rid of the p. Now I can get rid of the 1, so I'm going to minus 1 to both sides so that I can cancel out those 1's. And a over p minus 1 is just going to be a over p minus 1 equals or over 100. So just bring down the or over 100. Now I have or over 100, which means or divided by 100, and the opposite of divide is multiply. So if I want to get rid of that 100, I'm going to have to multiply by 100 so that they cancel out and I get the or on its own. If I multiply by 100 on the right, I must multiply by 100 on the left. So I have the or all on its own now equals 100 multiplied by a over p minus 1. Make c the subject of the formula. A times a squared plus c is equal to b times b squared minus c, where a is not equal to minus b, and then find the value of c if a is equal to 1 and b is equal to 3. So I have a times a squared plus c equals b times b squared minus c. First thing I'm going to do is multiply out my brackets. A times a squared is a cubed, a times c is ac. A letter times a letter, we just stick them together. B times b squared is b cubed, b times minus c is minus bc. So I'm trying to get the c on its own, so what I want to do is bring anything that has a c onto the same side, and anything that doesn't have a c onto the other side. So at the moment I have ac, so I'm just going to keep that there, and then the a cubed needs to go over to the other side. So I'm going to bring the a cubed over the equal sign, and it becomes minus a cubed. The b cubed doesn't have a c in it, so that can stay on the right hand side. And the minus bc does have a c in it, so that's going to have to come over the equal sign as well. So when I bring the minus bc over the equal sign, it becomes plus bc. So the a cubed went over the equal sign, became minus a cubed. The minus bc went over the equal sign, became plus bc. and the AC stayed where it was, and the B cubed stayed where it was. Now I have everything containing a C on the left and anything without a C on the right. So now I can factorize. I can pull out the C. C into AC leaves me with A. C into BC leaves me with B. So now I almost have the C on its own. I just have to divide by AB, because at the moment the C is multiplied by AB, so that they cancel out. But if I divide by AB on the left, I have to divide by A plus B on the right. So I get C equals B cubed minus A cubed over A plus B. Now the C is on its own, so I've made the C the subject of the formula. Now I just have to sub in A is equal to 1 and B is equal to 3. So do that here. I get 27 minus 1 over 4, which is 26 over 4, which is 13 over 2. Write D in terms of C and E if E equals 2C minus D over D plus 1, where D is not equal to minus 1, E is not equal to minus 1, and then find the value of D if C equals 6.7 and E equals 1.3. So the first thing I'm going to do is change the E to be E over 1, so that I have a fraction on the left of my equal sign and a fraction on the right of my equal sign. Then I'm going to cross multiply. E multiplied by D plus 1, I'm just going to write out here. And then 1 multiplied by 2C minus D is just going to give me 2C minus D. Now I can multiply out my brackets. E times D is DE. E times 1 is just E. And that's still equal to 2C minus D. I'm trying to make D the subject of the formula, so now what I want to do is bring anything that has a D over to the same side and anything without a D over to the other side. So DE has a D in it, so that's just going to stay on the left-hand side. E does not have a D in it, so I'm going to move that over the right-hand side. And it's going to become minus E. So a plus goes over the equal sign and becomes minus. The 2C doesn't have a D in it, so that can stay on the right-hand side. And then the minus D clearly has a D in it, so that's going to come over the other side. And it's going to become plus D. So the DE stayed where it was. The plus E went over the equal sign, became minus E. The 2C stayed where it was, and the minus D came over the equal sign, became plus D. Now I have everything that has a D in it on the left-hand side, and everything without a D on the right-hand side. So I'm going to factorize. I'm going to pull out the D. D into DE leaves me with E. D into D goes once. And 2C minus E stays the same. So now I have D multiplied by E plus 1. The opposite of multiply is divide. So I'm going to divide by E plus 1 so that they cancel out, leaving me with the D on its own. But if I divide by E plus 1 on the left, I must divide by E plus 1 on the right. So I get 2C minus E divided by E plus 1, which is 2C minus E over E plus 1. So D is now the subject of the formula. And now I'm going to swap the C for 6.7 and the E's for 1.3, multiply it out, and I end up with 5.26. Obtain T as the subject of the formula. We have E equals the square root of T minus K divided by K times 1 plus KT, where K cannot equal 0, K cannot equal minus 1 over T, and K squared E squared cannot equal 1. So what I'm going to do is change the E to be E over 1. I'm going to multiply out my denominator. K by 1 is K. K by KT is K squared T. And the square root is going to come over the equal sign and become squared. Now, if a square root comes over the equal sign and squares what's on the left, it's going to square the numerator and the denominator. But 1 squared is still just going to be 1, so I'm not going to bother squaring that. So I have E squared over 1 is equal to T minus K divided by K plus K squared T. Now I'm going to cross multiply. It's going to be E squared times K plus K squared T. So E squared times K plus K squared T is equal to 1 times T minus K, which is just T minus K. I'm going to multiply out these brackets. E squared times K is E squared K. E squared times K squared T is E squared K squared T. This is equal to T minus K. Now what I want to do is get anything involving a T over the same side, because that's my subject. So, and anything without a T needs to go on the other side. So E squared K, that doesn't have a T in it, so that's going to go over the equal sign. And E squared K, when it goes over the equal sign, becomes minus E squared K. e squared k squared t has a t in it, so that just stays on the left of the equal sign. T clearly has a t in it, so that's going to come over the left of the equal sign, and it's going to become minus t. Then I've got the equals, and minus k stays on the right hand side, and then I've got the minus e squared that I brought over from here. So e squared k comes over, becomes minus e squared. E squared k squared t stays on the left. Then I've got my equals. T comes over, becomes minus t, and minus k stays on the right. So now I have everything that has a t on the left and anything without a t on the right, because I'm trying to make t the subject. Now I'm going to factorize. I'm going to pull out the t. T into e squared k squared t leaves me with e squared k squared. T into minus t goes minus 1 times. And the right hand side stays the same. So now I have t multiplied by e squared k squared minus 1. So I'm going to divide by e squared k squared minus 1 so that they cancel, leaving me with the t on its own. If I divide by e squared k squared minus 1 on the left of the equal sign, I must divide by e squared k squared minus 1 on the right of the equal sign. So I have minus k minus e squared k divided by e squared k squared minus 1, or minus k minus e squared k over e squared k squared minus 1. So now I have t as the subject of the formula, or I could write it as positive k plus e squared k squared divided by minus e squared k squared plus 1. Express d in terms of v, g and h if v is equal to the square root of gd multiplied by 1 plus 3h over d. Then find the value of d if v is 12.2, g is 9.8 and h is 4.5. Well, the first thing I'm going to do is bring the square root over the other side and it becomes squared. So I've got v squared on the left. And then I just have everything that was already on the right except for the square root sign. So the square root sign went over the equal sign and became squared. Now I'm going to just multiply out the brackets. GD multiplied by 1 is GD. And GD multiplied by 3h over d is going to be 3gdh over d. So if I just have a look up here, I can see this done out properly. So GD can be written as GD over 1, because any term can go over 1. And this is being multiplied by 3h over d. And we're going to do top by top, bottom by bottom. So GD times 3h is going to be 3gdh. We basically just stick them all together with the 3 in front. And 1 times d is just d. Now I can see that the d's will cancel out above and below, leaving me with 3gh over 1, which is just 3gh. So now I've got v squared equals gd plus 3gh. I'm trying to make d the subject, so I want to get the d on its own. So I need to bring the plus gh over the other side, and it's going to become minus 3gh. So now I've got the d almost on its own. To get it on its own, I need to divide by g, which will cancel those out. If I divide by g on the right of the equal sign, I must divide by g on the left of the equal sign. So I get v squared minus 3gh over g. Now d is the subject. I just have to sub in 12.2, 9.8 and 4.5, and then 9.8 in my denominator as well. Multiply it out and I end up with 1.69.